Good morning. So today we'll start with the next chapter on vector algebra. First we'll discuss the introduction to the scalars and vectors. While studying the physics, on many number of occasions we need to describe various physical quantities. These physical quantities are classified mainly into two classes. Number one is the scalars and the other is vectors. Now let us try to understand what is the meaning of these scalar quantities and vector quantities. Whenever we want to describe the physical quantities, some of the physical quantities can be completely described only with the help of their magnitude alone, and such physical quantities which can be completely described only with the magnitude alone are called as scalars or scalar quantities. For example, if we consider the case of, say, mass, the mass of an object can be expressed either in gram or kilogram or whatever it is, quintal, tons, etc. So for the description of this quantity, only the magnitude of this quantity is enough to describe that quantity completely. We need not have to state about the sense or direction of that quantity. So such quantity which can be completely described only with the help of their magnitude alone and no need to describe the direction or the sense of that quantity, such quantities are called as scalar quantities. Another example is the time. Time is also a scalar quantity. Then we have the temperature. Temperature of an object can be described only with the help of its magnitude alone. So it is a scalar quantity. Then the speed of a vehicle or any object, moving object. The speed can be described completely only with the help of magnitude alone, so it is a scalar quantity. Then the pressure of a gas enclosed in an enclosure or a tube, that is also a scalar quantity. Work done is a scalar quantity. Then the potential energy or kinetic energy are again the examples of scalar quantities. Another example of scalar quantity is the electrical charge. So all these physical quantities such as the mass, time, temperature, speed, the pressure of gas, work done or simply work, potential energy, kinetic energy, then the electrical charge, all these physical quantities can be completely described only with the help of their magnitude alone, and hence such physical quantities are called as scalars or scalar quantities. These scalars or the scalar quantities can be added or subtracted by using the simple algebraic laws. The only thing that you must remember here is that whenever we want to add the two quantities, the two quantities should have the same unit. For example, if we want to add 1 kilogram of mass to 10 degrees of temperature, can it be possible to add the mass and temperature? Not possible. So whenever we want to add the two quantities, the two quantities should have the same units. So if one person has a mass of say 10 kg and another person has a mass of 20 kg, these two masses can be added together to give the 30 kg. But we cannot add mass to pressure or mass to temperature or any such different quantities which have the different units cannot be added together. So we can add or subtract these scalars by using the simple laws of algebra. The second quantity is the vectors. What are the vectors? If we want to describe a vector quantity, the only magnitude of this quantity is not sufficient to describe it completely, but in addition to the magnitude, we need to represent the direction of that quantity in order to get the complete idea about that quantity. So, such quantities which can be completely described with the help of their magnitude as well as the direction or sense of that quantity are called as the vector quantities or simply vectors. For example, if we consider the case of a displacement, if we have an object initially existing at the position A, and if this object moves in certain direction and after a certain time it acquires the position say B. So in time t, say this is the position of the object at instant t equal to 0 and this is the position of the object at instant t equal to t1. During this time from 0 to t1, the object has displaced from position A to the position B. So if we are interested to know what is the displacement of this particle during the time from 0 to t1, what we need to do is we have to draw a directed line segment joining the initial position of the particle to the final position of the particle, and this is called as a vector because only magnitude, the distance of between the points A and B is not sufficient to describe the displacement of this particle, but as well we need to give the idea about in which direction the particle has displaced. So in this case the particle has displaced towards the right or in this direction. So to describe the displacement of the particle, we need to give the magnitude of this quantity as well as the direction in which the particle has displaced. If we simply give the magnitude of this quantity, the particle may be displaced in any direction with the point A as center and having the distance same everywhere on the circumference of this circle. So to get the complete idea where the particle will be at instant t1, we should give the specific direction of that displacement, and such a physical quantity which can be completely described with the help of not only with magnitude but as well we need to specify the sense or direction of that quantity. Such quantities are called as vector quantities. So this is the first example of the vector quantity. Then the second example of vector quantity is the velocity. The velocity of a particle is a vector quantity. Then the acceleration. As we know that the velocity is defined as the rate of change of displacement, and since the displacement itself is a vector quantity, the rate of change of displacement also is a vector quantity, and that is nothing but the velocity. Next is the acceleration. Since acceleration is expressed as the rate of change of velocity with respect to time, the acceleration is also a vector quantity. Then the momentum. As we know that the momentum of a particle is expressed as the product of mass of the particle and its velocity. And since the velocity is a vector quantity, the product of mass and velocity yields to be again a vector quantity. So the momentum is also a vector quantity. Then the force. If we act a force, certain force on a particle at position A, depending on in which direction the force is exerted upon the particle, the displacement of the particle will take place in the direction of the force acting on it. So force is again a vector quantity. Then the temperature gradient. The temperature gradient is also a vector quantity. If we place a certain source of heat at a certain point in the room, then depending on what is the density of the surrounding medium, the temperature, the heat energy is transferred from the point of source to the distant points, and depending upon the density or the properties of the medium, surrounding medium through which the heat energy is propagating, if the surrounding medium is uniform or isotropic, we can call it as heat energy will be propagated in all the directions uniformly, such that the temperature at a particular distance from the source will be equal at every point on the surface of a sphere of that distance. So this is called the temperature gradient. This is called as temperature gradient, and this temperature gradient is also a vector quantity. If the properties of the surrounding medium are not uniform, then the temperature gradient in different direction will be different. So the temperature gradient is a vector quantity. Then the next example of vector quantities is the electric and magnetic fields. Electric field is a vector quantity. Magnetic field is a vector quantity. In specific, the electric intensity and magnetic intensity are the vector quantities. Then the magnetic moment, dipole moment of a magnetic dipole, again it is a vector quantity. So these are certain examples of the vector quantities. These vector quantities also can be added or subtracted. Also we can take the multiplication of these vectors, the addition and subtraction of the vectors, as well as the multiplication of the two vectors we have studied earlier. Here also we are going to briefly revise how these vectors can be added, subtracted, and we can take the multiplication of the two vectors. The multiplication of two vectors can be performed in two different ways. We have studied the two type of products, the dot product or the scalar product of two vectors, and the second is the vector product of two vectors. The dot product or scalar product is nothing but if the result of multiplication of the two vectors yields to be a scalar quantity, it is called as a scalar product or dot product. And if the result of multiplication of two vectors results into a vector quantity itself, such product of two vectors is called as a vector product, or it is also called as cross product. So depending on how what is the result of multiplication of two vectors, the product of multiplication of two vectors is classified into two classes, the dot product and cross product, or scalar product and vector product respectively. So we are going to revise this dot product and cross product of two vectors in brief, and then most important point that we are going to study in this chapter is how to take the multiplication of three vectors. How to take the multiplication of three vectors. Just like we have seen, the result of multiplication of two vectors results into a scalar quantity. Similarly, if the result of multiplication of three vectors results into a scalar quantity, it is called as scalar triple product. and if the result of multiplication of three vectors yields to be a vector quantity, it is called as vector triple product. So these two most important types of products of the three vectors we are going to study in this chapter, as well as we are going to study the physical significance of the scalar triple product as well as that of the vector triple product in this chapter. So that is the brief idea of this vector algebra, scalars and vectors. Then before we discuss how to perform the addition, subtraction and multiplication of the two vectors, let us revise in brief the representation of the vectors and the types of vectors. So let us first discuss the geometrical representation of a vector. Suppose we have this rectangular coordinate system, the two mutually perpendicular axes. The two mutually perpendicular axes, say this is the x-axis, this is y-axis. So this forms the xy plane, and these two mutually perpendicular axes intersect each other at this point O. This is the origin of this coordinate system, rectangular coordinate system, as you can say. Now, if at instant t equal to 0, we have a certain object situated at the point O, and this object is exerted upon by a certain force, and under the action of this force acting on the particle, this particle say displaces to the position Cp. Suppose this is the final position of the particle after some time or certain time t. So this vector OP bar represents the displacement of the particle, or this vector OP bar is also called as the position vector of the particle. So this vector OP bar is the position vector. Or it is also called as the displacement vector of the particle. These vectors are represented with the help of a bar or an arrowhead over x. So this bar or arrowhead indicates that this is a vector quantity. Or else, if we represent this vector as A, to indicate that this is a vector, we have to represent this arrowhead over its head. So this is how we can represent a vector. So, or else this vector A bar also sometimes is represented with the bold type A. With this bold A also sometimes the vectors are represented. So either we can represent a vector with an arrowhead over its head, or simply by representing it with the bold letter A. The magnitude of this vector is represented like this: mod A bar, or modulus of a vector A bar, or simply sometimes it is also represented as mod E, or and this gives the magnitude of this vector. This modulus of this vector represents the magnitude of that vector, and arrowhead represents the direction of that vector. So This is the vector OP bar, the position vector, or it is also called as the displacement vector of the particle, and this vector is drawn starting from the initial point of the particle to the final position of the particle, and the length of this line represent the magnitude of that vector, and this arrowhead represents the direction in which the particle has displaced. This arrow indicates that the direction in which the particle has displaced. So whenever we want to describe this displacement of the particle completely, only magnitude of that particle, displacement is not sufficient, but we need to specify the direction of the displacement. So this physical quantity can be described completely only with the help of its magnitude as well as direction. So such quantities are called as vector quantities, or simply vectors. Then let us see the types of the vectors. So that is how we can represent the vectors geometrically. So with the help of this geometrical representation, we can represent the vectors. Then let us see what are the types of vectors. Mainly, the vectors are classified into two types. The first one is the polar vectors. First type of vectors is the polar vectors. Now, what is this polar vectors? As we have discussed just now, the displacement of a particle. This displacement vector is found to be directed from the initial position of the particle to the final position of the particle. Since this is a vector directed from the initial position of the particle to the final position of the particle, so this vector has a specific direction. So this displacement vector, or the velocity vector, or the force vector, these vectors are such that they are pointing in a specific direction or towards a specific point. So such vectors which are directed towards a specific point or in a specific direction are called as the polar vectors. So these vectors are also sometimes called as radial vectors. These vectors are also sometimes called as radial vectors. So that is the first type of vectors, the polar vectors: displacement, velocity, force. Then we have velocity, force, etc., which are having a specific direction. These vectors are since directed towards a certain specific point. So such vectors are called as polar vectors. The second type of vectors is the axial vectors. Axial vectors. Whenever we are considering the case of rotational motion, suppose we have a particle performing a rotational motion around the circumference of a circle. Say the particle is revolving in the anti-clockwise direction. say the plane of rotation of this particle is in the horizontal plane, and the sense of rotation of the particle is in the anti-clockwise sense. Then at certain instant t, the particle is at A. If we draw the line joining the center of the orbit to the position of the particle at instant say t1, the vector OA bar is the position vector at instant t1. Since the particle is rotating around the circumference of this circle, at a later instant t2, say the particle moves to the position B at instant t2, we can draw the position vector of the particle as OB bar. OA bar is the position vector of the particle at instant t1. OB bar is the position vector of the particle at instant t2. So during the time from t1 to t2, the position vector of this particle has rotated through this angle theta. So this is the angular displacement of the particle, and this angular displacement of the particle is a vector quantity. Now, when we want to describe what is the angular velocity of the particle, what is the angular acceleration of the particle, what is the torque acting on a certain particle, how do we represent? Since we know that the angular velocity is defined as the rate of change of angular displacement with respect to time. Here the angular displacement is directed in this direction. So the rate of change of this angular displacement with respect to time has a certain magnitude. And what is the sense or direction of this angular velocity? To represent the sense or direction of this angular velocity, what we do is we draw the line perpendicular to the plane of the orbit of the particle, and depending on what is the sense in which the particle is rotating, we have to represent the angular velocity of that particle. For that purpose, to know the sense or direction of this angular velocity, we can make use of the right hand thumb rule. What is the right hand thumb rule? As we know that we have these 4 fingers of the right hand and the thumb is stretched out. If we curl the 4 fingers of the right hand in the sense of rotation of the particle, then the stretched thumb represents the direction of that angular velocity. So here, since the particle is revolving in the anti-clockwise sense in the horizontal plane, so if we curl the 4 fingers of the right hand in the sense of rotation of the particle, then the stretched thumb, since it is pointing in the upward direction, this is the direction of the angular velocity of the particle. So the angular velocity of such particle is found to be directed perpendicular to the plane of the orbit of the particle and is pointing in the upward direction. As well, since the angular acceleration is defined as the rate of change of angular velocity, the angular acceleration alpha is also found to be directed in the same direction as that of angular velocity. So these are the quantities which are associated with the rotational motion, and these quantities that are associated with the rotational motion are represented with the help of these vectors, and such type of vectors, these vectors are found to be directed along the axis of rotation of the particle. The line passing through the center of the orbit and perpendicular to the plane of the orbit is the axis of rotation. And since these quantities, the angular velocity, angular acceleration, as well as if we have the torque, so all these quantities are since directed along the axis of rotation of the particle, the such quantities, such vectors rather we can say, are called as axial vectors. if we have this object, if this object is exerted upon by a certain force, equal force, two equal and opposite forces are acting on this object at two different points, then what will happen? The result of these two forces acting on the particle at two different points, two different positions, will result in the rotation of this object. It will result into the rotation of this particle, and this is called as the torque. The result of two equal and opposite forces will produce the rotational effect in the body, and this is called as the torque. So this torque too is given by the magnitude of one of the force and the distance of the force from the axis of rotation. Say if r is the distance, the F bar cross R bar gives the torque acting on the particle, and since it is the cross product of force and distance of the force from the axis of rotation, this results into a vector, and the magnitude of this vector is Fr cos theta. And what is the direction of this torque? The direction of the torque can be obtained by using again the right hand thumb rule. So if the rotation is produced in the anticlockwise sense, if we curl the four fingers of the right hand in the sense of rotation of the body, then the stretch the thumb represents the direction of the torque acting on it. So this torque can be represented to be directed in the upward direction. So since again this torque is found to act along the axis of rotation of the body when two equal and opposite forces are exerted upon it at two different points. So this is again the example of axial vector. So mainly the vectors are classified into these two types, the polar vectors and axial vectors. So if these vectors are directed towards a specific point, it is called as displacement, velocity, force. Such vectors are called the polar vectors, and the vectors which are found to be directed along the axis of rotation of the body. This type of vectors are associated with the rotational motion, and such vectors which are found to be directed along the axis of rotation of the body are called as the axial vectors. So with that we will conclude here for today, and again the vectors are classified on the basis of their magnitude and direction and all that. So that classification of the vectors will continue in the next video. Okay.